Okay, so continuing along our trig journey. So we did some basic right triangle trig before Thanksgiving, which was a 100% review from geometry. Most of this should be a review, but maybe not all of it. Some of it definitely is, but it kind of depends on, where or how much your geometry teacher went into things. All right, so let's talk angle measures. So we're used to angles being in figures, whether they're in triangles or rectangles or, any kind of other figure. But we're going to be talking about them on the coordinate plane. So no longer just, in polygons and things. So, and when they're on the coordinate plane, they can be anywhere, but we're going to be talking about them mostly in standard form. So an angle in the coordinate plane in standard form is when the vertex is on the origin and one ray lies on the positive x-axis. Okay, so this angle right here is in standard form. Here's your ray that lies on the x-axis. Okay, so the ray that's on the x-axis is called the initial side, because it's where we start. Then if you think about them starting on top of each other, then the other ray is going to rotate around, and they're attached right here at the origin. So the other ray, the one that actually gets to move, so is called the terminal side, because that's where it terminates. Okay. So this other ray, which is the terminal side, can rotate counterclockwise or it can rotate clockwise. So if it's a counterclockwise rotation, that results in a positive angle measures, and clockwise rotations result in negative angle measures. And then that kind of explains why we number the quadrants like we do, because when you first learn your quadrants, if you're thinking, I don't really understand why we number them that way, we are left to right kind of people, so it would make more sense to be 1, 2, 3, 4. But then once we get to this, we understand why. If I start here and I'm at 0, this is quadrant 1. I'm going to rotate counterclockwise, so this is the second one I hit. This is quadrant 2. Then this is quadrant 3, and this is quadrant 4, and then the numbering makes a little bit more sense. All right, so we are used to measuring angles in degrees. So the most common unit of measure for an angle is the degree, right? And if anybody knows anything about angles, they understand degrees. It's just the way that it is. But there are other ways to measure, similar to, but not exactly the same as using feet versus meters, that sort of thing. But that's more of just a conversion. This is kind of a totally different type of measurement. But when we get to radians, okay, but we're just still talking degrees. So a degree, so if I make 360 degrees all the way around, then a degree, one of them, is just 1/360th of a full rotation. So we are going to sketch these angles, and we have to sketch them accurate to within 10 degrees. That's what Delta Math is going to expect you to do, but that should be no problem if you understand how to think through them. So if I want to sketch a 135 degree angle, I start here. This is one side of the angle, right? This side doesn't move. There's another ray that's going to get to rotate. This is positive, so I'm going to rotate positively from here. So if I rotate this far, I'm at 90. So I've got to go a little bit farther. So if I do 135 minus 90, what does that give me? 45. So that means I have to go 90 and then another 45, which would be halfway. So that's what my angle looks like. But in addition to that, I have to show the direction of rotation to show this right here. Show that I start here and end here, and that this is 135 degrees. So when you're in a triangle in Euclidean space, you can't have an angle bigger than 180, but that doesn't mean that those angles don't exist. You can have an angle bigger than 180. You can have an angle bigger than 360. You can have an angle of any measurement you want. All right, so let's look at this 495 degree angle. I know I'm starting here. I know that if I start here and I rotate all the way around to 360, I haven't got to 495 yet, so I got to figure out how much more I need to go. So if I take 495 and subtract 360 from it, how much farther do I have to go? 1 35. So I actually end up in the same spot I do for number 1. But they are not the same angle, so I have to make sure that when I label it, it doesn't look like it's the same angle. Because I didn't start here and just end here. I started here and I went all the way around and then I ended here, and that is 495 degrees. Okay. Any questions at this point? All right. So then I have a negative 140. So again, I start right here. This angle is negative, so I'm going to rotate clockwise. So if I go from here to here, that's a negative 90. And then I have to go how much more? Negative 50, right? So that's just a little bit past halfway. And then I have to make sure that I label so I know that I didn't go this way for a positive angle. I went this way. And that's my negative 140 degree angle. All right, any questions at all? Okay, so I got a little ahead of myself when I was talking about degrees. I was so excited to get to radians. Because in the end, you will like radians way more than you do degrees. When we start getting really into this stuff, radians are actually a lot easier than degrees. You just don't always believe that at the beginning because you're more comfortable with degrees. But trust me, okay? So let's read what this says about a radian. So a radian is a unit of an angle measure based on arc length. Okay, so radians are definitely something you should have seen in geometry when you were talking about arc length and stuff. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. All right, so let me show you a little video that...
We start with a circle of radius r. We take that radius distance and wrap it around the circle. The angle formed by that radius distance is 1 radian. Since the circumference of a circle is 2 pi r, there should be 2 pi radiuses in a circle. So halfway around the circle, we would expect 1 pi radian, and around the entire circle, we would expect 2 pi radians.
Kind of explains that. All right, so what they were saying was, here's your circle, right? So if I take the length of that radius, whatever it is, and I bend it around the circle, like so, then that little red line, or that red line segment, which is now a red arc, is the length of the radius. And so that's about 57 degrees. That measurement doesn't actually matter to you, okay? But I can take that radius, and then I'm going to repeat it around the circle. And when I get halfway, so that's 1, 2, 3, right? And then I go a little bit more, so it's actually 3.14159 radians. So it's pi radians is halfway around the circle. So then if I go all the way around the circle, that is 2 pi radians. And the circumference of a circle, 2 pi r, right? And if the radius is 1, because in a unit circle, there's your circumference, it's 2 pi. So it's the ratio of the arc length to the circumference. That's how you find a radian. Just understand that it's a different type of measurement than a degree, because a degree is like, you know, how bendy it is, and then the radian is kind of how long it is. But either way, we're just going to have to convert one way or the other. Okay, does that make sense where it comes from? Yes, just like there's always 360 degrees in a circle, there's always 2 pi radians in a circle. Okay, it's a good question. All right, so let's continue this then. So that's what those words meant there. So here's my radius. We know that this is the radius, this is the radius, those are congruent, right? And then this is just, so it's almost like an equilateral triangle, except it has an arc for a side, but that's 1 radian. So 360 degrees, if I go all the way around the circle, that gives me 2 pi radians. Even though on degrees, you have to have that degree symbol to say that it's 360 degrees, we normally don't put that rad or radians after the measurement. We just don't. I don't really know why that is, but that's why it is. So that means 180 would just be pi. Okay, so 2 pi for 360, 180 is pi. So if I have to convert, just like from feet to inches or from feet to meters or whatever, I need some sort of conversion. So if I want radians and I have degrees, I'm going to multiply by pi over 180 because that's the ratio, right? For every 180 degrees, I have pi radians. And if I want degrees and I have radians, I multiply by 180 over pi. How do you keep straight which one you want? Well, if you want radians, you got to get the pi in there. And if you want degrees, you got to get the pi out of it. You can talk about radians as whole numbers and decimals. So I could say I have 1.347 radians. But that's not how we're looking at it right now. Everything's going to be exact, which means that there should be a pi in your answers or when you see radians for right now until we really get the hang of it. Okay. So we're going to convert. So it says convert each angle measure to radians and state the quadrant. All right, so let's start by stating the quadrant. If I have 60 degrees, which quadrant am I in? 1. So I'm in the first quadrant. That's our Roman numeral 1. So if I have degrees and I want radians, I'm going to multiply this by pi over 180. And then I can divide them both by 10. So that gives me 6 pi over 18, which is really pi thirds. Everybody good with that? Easy enough? All right, 160 degrees. What quadrant is that in? 2, okay? Because 180 would get me all the way there, so this is 2. So I'm in quadrant 2. I'm going to multiply by pi over 180. I can just put that over 1. Then divide them both by 10. Then I can also divide them both by what? 2. So I get 8 pi over 9. Any questions at this point? All right, so I can also have negative angles. So that negative 330, what quadrant would that be in? 1, because I would go it'd be negative, so I'd have to go negative to 330 because 360 is right there, so I only have 30 left. So I'm in quadrant 1 again. So I'm going to multiply by pi over 180. And divide them both by 10 to get rid of the zeros. I know it's going to be negative. Then I have 33 pi over 18. What else can I divide by? 3. So I get 11 pi over 6. So it's negative 11 pi over 6. Any questions at all? All right, so now we're going to convert from radians to degrees. And we're going to think about the quadrants before we convert, right? And I know that radians are, even though they should not be brand new to you, they're not something that you're used to thinking in and thinking in terms of them. So we're going to help you, walk you through it, how you want to think about what's happening on the coordinate plane. If this is 0 radians, all the way around is 2 pi radians. Does that make sense? So halfway is pi. So between 0 and pi, halfway right here, what would that be? What would I have to do to this to get it halfway? Divided by 2, so it's pi over 2. Very good. So for the quadrants, you want to think in terms of halves. So if this is 0, this is pi halves. This is 2 pi halves, which becomes pi, right? Which means this is 3 pi halves. And then this becomes 4 pi halves, and that's where you get your 2 pi from. But you can think in halves. Okay, does that make sense to you? So that's, you think about these fractionally no matter what the denominator is. So this denominator is 18. If I go from 0 to pi, this would be 18 pi over 18. Do you agree with that? Halfway would be 9 pi over 18. This is 5 pi over 18, so which quadrant is it in? 1. Do you see how you can reason through it even if you don't know what the actual angle measure is yet? You need to be able to reason around the circle that way. Okay, so now we're going to convert. We're going to multiply this. I need to get the pi out of it, so this is going to be 180 over pi. The pi's cancel out. 18 goes into 18 once, goes into 180 10 times. So then I have 5 times 10. That's 50 degrees. And that is in the first quadrant. So you end up being able to check yourself anyway in the end. Everybody good with that? Okay. So now let's look at number 8. So this is in terms of ninths, and it's negative. So if I start here, and I go to negative pi, that's negative 9 pi over 9, right? So negative 11 pi over 9 would be in which quadrant? The second, right? In the second quadrant. And again, we'll be able to check ourselves in just a minute if we're not sure. Then I'm going to multiply by 180 over pi to get out of that. The pi's cancel out. 9 goes into 9 once, goes into 180 20 times. So now I just have negative 11 times 20. What's 11 times 20? 220? Yes, okay. So I have, it's negative, right? So I'm in ninths. So if this is 0, this is negative 9 pi over 9, right? And so this would be negative 18 pi over 9 if I kept going. And so this one's a little trickier because you kind of have to do like the halves. So this would be like negative 13.5 over 9, which doesn't even make sense. But you can, think about it value-wise, which means that negative 11 pi over 9 has to be in quadrant 2. Okay, that's a good question. Anything else? Okay, so let's talk about 7 pi thirds. So now I'm thinking in thirds, and it's positive. So this is 0. This is 3 pi thirds, which means all the way around would actually, it's 2 pi, but it would be 6 pi thirds when I think in terms of thirds, right? So 7 pi thirds, but I have to go one more third, and I'd be in quadrant 1. And just so I know with the radians right now, again, you might feel like you're maybe kind of guessing, but you can always check yourself. This will become much easier and much more obvious to you pretty quickly as we get into radians. Okay. All right, so 7 pi thirds. Oh, I need to convert now. So I'm going to multiply this by 180 over pi. I'm going to cancel the pi's. 3 goes into 3 once, goes into 180 60 times. So I just have 7 times 60, which is 420 degrees. Any questions at all at this point? Okay, the good news is that as far as thinking around the circle fractionally, we truly only have to be able to do that in thirds, fourths, and sixths. Okay, and then we'll be doing the same thing over and over again, and you won't even have to think that hard anymore after a while. All right, so let's look at coterminal angles. Okay, so terminal is where it terminates. Co is like together, like your coworkers, you work together, right? So this pi halves, one of the coterminal angles that I have with pi halves, or 90, is negative 270 or negative 3 pi halves, because basically there's 2 different ways to get here. If we all went outside to the track, we were going to run around the track, right? And we started here, you could run this way, I'll run this way so I don't pass out, and we can get to the same spot, okay? I mean, you could even lap me, you could lap somebody else, and you could keep going around and around and around, and boom, you end up there. Whatever angle measure that is, it's a coterminal angle. It's a different way to get to the exact same spot, all right? So this says, and there's all kinds of typos in this sentence, it says find an angle, theta, coterminal to the given angle where theta is between 0 and 360, or theta is between 0 and that should be 2 pi, not pi. I typed quickly and then didn't proofread. Okay, so I have 544 degrees. That's not between 0 and 360. So that means I would start here, I'd go around, and then I'd have to go around some more. So to figure out what your coterminal angle is, whatever this is, it's just another rotation to get there one way or the other, which means in degrees, I could add or subtract 360 degrees, and I could do it more than once, so it's going to be 360 times n. N could be 1 rotation, or it could be 2. It's just like the number of rotations you have to get there. Same thing for the radians, it would just be plus or minus the 2 pi times n. So since I have 544 degrees and I need to get it down under 360, I'm going to start by subtracting 360. Okay. So before I say, what is that? And you all just stare at it for a long time and then people start guessing numbers, because I know you know how to subtract. But most of you, not all of you, but most of you aren't going to borrow and mark it. You're going to stare at it and try and reason through it, which is fine. But some of us don't have good reasoning skills for that. If you want to think about how to think through this to make your life a little bit easier, take the 544 and first just subtract the 300. So you're down to 244 minus 60. Does that make sense? Then I'm just going to subtract 44 to get down to 200. So that means I'd have 200 minus 16. And then that's a whole lot easier. What does that give you? 184. So do you see how to do it in stages instead of staring at it and then sometimes you're off by a 10 or 100 because you forgot to borrow or whatever? Is 184 between 0 and 360? Yep, so this is my theta. So whether I have an angle that's at 184 degrees or 544 degrees, they have different measures, but you're going to end up at the same spot on the coordinate plane. So then I have this 170. Well, it's negative. So I need to get to 360, or between 0 and 360. So I'm not going to subtract 360, I'm going to add 360, which is really the same as 360 minus 170. So again, let's do it in stages. 360, let's just subtract 100. So I get 260, and then I would be minus 70. And then what's that going to give me? Because then I'd have 200 minus 10, right? So that's 190. Because last period when I didn't talk about that, like the reasoning first, I got a lot of people trying to tell me 290. And that's the kind of mistakes you make when you subtract. I know you know how to do it. The thing is that you don't always do it. Since you're not writing it down, you don't actually do those things, and then you get silly things wrong. So that is your theta, because that is between 0 and 360. But again, I might have to add 360 again or subtract 360 again multiple times to get where I need to be. Okay, so now I have 11 pi over 2. And I know that I'm going to add or subtract 2 pi in. But I have to get a common denominator. But instead of thinking about it as a common denominator, think about the fact that you're thinking in halves, right? If this is 0, this is 2 pi halves. So to go all the way around, that's actually 4 pi halves. So 2 pi is 4 pi halves when you think in terms of halves, right? So 11 pi halves is definitely bigger than 4 pi halves. So I'm going to have to subtract. So I'm going to subtract 4 pi halves. So that's going to give me 7 pi halves. Well, if I know that 2 pi is the same thing as 4 pi halves, 7 pi is not less than 2 pi, right? Which means I need to subtract 4 pi halves again, and that's going to give me 3 pi halves. Is 3 pi halves between 0 and 2 pi? Yes, because it's less than that 4 pi halves, so this is your theta. It just was a couple of rotations to get there. So I kind of wish I'd used a different denominator on 13, but I didn't. So we're still thinking in terms of halves. If that was 5 pi thirds, then I would be using 6 pi thirds instead of 4 pi halves. But I have negative 5 pi halves, so I'm going to need to add this time. So I'm going to add 4 pi halves to go the other way. So that leaves me with negative pi halves. Well, that's not between 0 and 2 pi because it's negative, right? So I need to add another 4 pi halves. And then what does that leave me with? 3 pi halves. So I actually get the same angle as I did here, which is a coincidence. You won't always get this answer. So that means 11 pi halves, negative 5 pi halves, and 3 pi halves, they're all coterminal angles. Different ways to get to the same spot. It's just that that one's the only one that satisfies the between 0 and 2 pi part of it. Okay. Any questions at all? Okay. We're not going to do this part because basically we don't need to. It's just more coterminal stuff. I don't think it's necessary. So let's talk about reference angles. Because understanding how to find the reference angle and what a reference angle actually is super important, and they are going to make things so much easier when we start talking about the unit circle. It's basically going to save your life if you can understand reference angles. So it says for an angle theta, and it has to be in standard form. It's really all we're talking about. The reference angle, here's the important stuff, is the positive acute angle formed by the terminal side in the x-axis. It's always positive, it's always acute, and it's always the shortest way back to the x-axis. When you're talking about a reference angle, the reference angle isn't necessarily in standard position. So it doesn't matter which direction you go, it's still a positive measurement because of the angle that we're talking about. Okay? So it says sketch each angle, then find the reference angle. Okay, so we're going to start with just a 150-degree angle. I know that I'm going to start here, right? 150 degrees. I'm going to go 90, and then how much more? 60, right? Okay, so let's think about how far that is, because remember, we have to be within 10 degrees in delta math. So if this whole thing is 90, and I have to go 60, that's 2/3 of the way, right? So you go about 2/3 of the way, and trust me, if you're actually attempting to do it correctly, you'll be fine within that. So this is my 150-degree angle. Okay? I want the reference angle. The reference angle is always the shortest way back to the x-axis from the terminal side. So this is my reference angle. So if this is 150 degrees, how big is my reference angle? 30, because I have to get to 180, right? So that makes my reference angle 30 degrees. Everybody okay with that? All right, so let's look at 315. I'm going to start here. I'm going to go around to get to here 3/4 of the way. That's 270. So 270, and then I would have how much more to go? It's 315 minus 270, 45. So that means I'm going to be halfway into the fourth quadrant. So this is 315 degrees. So my reference angle, shortest way to the x-axis, what would my reference angle be? 45. Because I just went halfway to get 45, so that means I got the other half to go. This is 45 degrees. Because when we start looking about what these angles tell us and all the information that comes along with them, I'm going to use that 45-degree angle to help me with the 315. Like, I don't have to remember what happens with 315 as long as I know what happens with 45 and I can connect the two. All right, so now let's look at negative 240. I'm going to start here. Right? I'm going to go a negative 180. And then how much more would I have to go? Negative 60. Good. So that means it's another like 2/3 of the way around there. So that makes this negative 240. The reference angle, shortest way back to the x-axis, because it's always positive and it's always acute. This is my reference angle. And what is the measure of that angle? What did we just do? We just went 180 and another 60, right? So what does that have to be? 60. I mean, usually when you're graphing the angle, the actual angle first, then the reference angle, you've pretty much already answered your question. You just kind of don't realize it. It's there. Okay, we good? All right, so we're going to do these radians, and the radians is in 3rd, 6th, and 4ths, which eventually you're going to become rock stars at. And so we're going to do this without converting. Okay, we're going to think about what this actually means. So if I have 5 pi thirds, right? So if this is pi, right? If 180 is pi, then pi thirds would be 1/3 of the way. What's 1/3 of 180? 60. So your pi thirds is 60, right? So we can think about it's like, you know, however far it is. So I'm going to start here. Start here. So 5 pi thirds. This is, if I go to pi, that is 3 pi thirds. If I go all the way here, that's 6 pi thirds. So I don't quite get there, right? I have a pi thirds left. So I should have about 2/3 left like that. So this is 5 pi thirds, which means my reference angle is how much? Pi thirds, exactly. 1 pi thirds, and it's fine that you're thinking about them in ones. You would just never see it written and you wouldn't write it, but it's fine to say it, but it would just be pi thirds. And if you notice in my reasoning to get there, I actually said it to myself. I said, look, all the way around is 6 pi thirds. I only want 5, so I have to back up pi thirds. So I backed up that much to get my angle, so my reference angle is pi thirds. So again, you kind of already answer yourself along the way sometimes. Okay, so if pi thirds is 60, then pi 6 would have to be what? Think about that. Pi thirds equals 60 degrees. So what would I do to this to get here? I'd multiply it by what? Not 2, but 1/2. I'd multiply it by 1/2 to get here, from here to here, right? So that means I'd have to multiply this by 1/2. This is 30. So if a third of it is 60, then a sixth of it is 30. It's like less than that, right? So pi 6, we're thinking in 30s now, but we're going to think in sixths. So I'm going to start here. If I go to pi, that is 6 pi 6, right? All the way around to 2 pi would be 12 pi sixths. And I have to keep going. I'd go one more. So it's about 30 degrees. It's about right there. So start here, go all the way around and back around here. This is 13 pi over 6. So then I have, what would my reference angle be? How'd I get there? What are you doing? Oh my gosh. Well, I want to wear it. Bring it to me. All right, so what is the measure of my reference angle? Pi 6. I'm sorry, I know we got interrupted there. Pi 6. All right. Everybody, because we went 12 pi 6 and then we want one more, right? Okay. So then let's think about pi fourths. If I go from here, well, here, go ahead. If I go from here to here, that's pi, right? This is pi halves. So pi fourths is halfway. So pi fourths is how many degrees? 45, yeah. Okay. So that means I'm going to start here. I'm going to go negative, when I get to pi, that's negative 4 pi fourths. Then I'm going to get one more to get to the 5 pi fourths. I'm right here. Is negative 5 pi fourths. So my reference angle, shortest way back to the x-axis, is this right here. What would that be? Yes, but in radians, you're right. Be pi fourths, right? So because I went negative 4 pi fourths, then one more to get to negative 5 pi fourths. So this is just pi fourths. And it's positive because it's always positive and it's always acute. And it is 45 degrees, but we're talking in radians. Okay. I was basically just thinking through this just so we could get it drawn accurately. I don't necessarily want you like converting them to figure it out, because you need to start thinking in terms of radians. And if you trust me, you will eventually see why radians are way easier to understand on all this than degrees. Any questions at all at this point? Do you have a question? You look like you have a question. You sure? Okay. All right, so let's talk about quadrantal angles. So what if they're not in a quadrant? Like I can tell you which quadrant each one of these angles is that we just did, but sometimes they're not in a quadrant, they're on an axis. So when the terminal side of an angle theta, that's in, again, standard position, lies on the x or y axis, then it's called a quadrantal angle. So if I have 0 degrees, I'm here. My initial and terminal sides are right on top of each other because I'm at 0, or I'm at 2 pi, or I'm at 4 pi, or any of the coterminal angles there, then it's not in a quadrant. It's a quadrantal angle, but then I have to clarify it's quadrantal and it lies on the positive x-axis. Okay. So then 90, or pi halves, or negative 3 pi halves, or any other coterminal angle that's going to end me up there is a quadrantal angle, and then I would also say that it is on the positive y-axis. Okay, so then theta is 180, or pi, or negative pi, or any other coterminal angle. I say that it's quadrantal, and it's on the negative x-axis. Then if I'm at 270, or 3 pi halves, or any other coterminal angle that lands me there, then I'm on the negative y-axis. What questions do you have? Anything at all?